This lecture or video is about 2.2 and the normal curve. So what is the bell curve? In class, we just, everyone gave an answer for what they had heard or what they already know about the bell curve. So some things that were mentioned is it is symmetrical. Let me actually turn my volume up. Okay. So it is symmetrical. It has one peak. It is mound-shaped. And really, those are the big three that we need to worry about. If we were to draw it, it would look something like that. That one came out okay. So it's bell-shaped. If you said that instead of mound-shaped, that's A-okay. But it's symmetrical and one peak, mound-shaped. All right. There are a few more little things about it in terms of standard deviations, but we'll get to that here in a little bit. So next, we looked at this picture of data. This is a collection of Iowa test scores, and conveniently, it looks a lot like what we just saw, a bell curve. Before we dive into this distribution exactly, we have a new term, and that's a density curve. So that's for continuous distributions, like anything that's a form of a measurement. Whenever you graph it and you draw the line above it, like the red line in the picture you see at the bottom right, it's called a density curve. So a density curve is something that's always above the horizontal axis. If I was to calculate somehow using calculus or stats or a computer program, if I was to calculate the area under the curve, the entire area, it would be 1.0, 1.0, or in terms of percents, 100%. So a density curve, I'll make a note, is for continuous data. An easy way to distinguish continuous from discrete is we're talking about measurements of some sort. So if you can argue that your data is a measurement, like these are scores, it's a measurement of how these 7th grade students did on a test. All right? And if ever it's symmetrical at the very bottom of the screen, if anytime you have a symmetrical graph, you know the median is approximately equal to the mean. All right? Okay, so let's press on, look at some more pictures. I mentioned density curves, so I drew a bunch. These are all density curves. This one, top left, has positive skew. Top right has negative skew. And of course, you could say left skew. You could say right skew. Those words are interchangeable. This one is normal. That's the word we use for a bell curve. This one is flat and symmetric, but the formal name for this one is uniform. So let's pretend that I drew a picture of the entire distribution of some 4 hypothetical distributions. So like if I was to shade, let's start with the easy one, this entire distribution, the area would equal 1. And same for the other 3. So let's say on the right one, this is the beginning, this is the end, and you shade the entire area. That proportion that I just shaded is 1.0. So it's a proportion. It makes almost more sense, the 1.0, when you convert it to a percent. I just shaded 100% of that distribution. And likewise for that one, this normal one, if I shade it, it'll be 1.0. If I shade the left one, it'll be 1.0. And what we're about to do is shade a portion, like an interval, specific interval. And we're going to see if we can figure out specific proportions on the normal curve. We're not going to deal with skewed or uniform right now. All right. So pressing on. If something's normal, we already kind of said it at the beginning of this video. We know that it is symmetric. We know it has a single peak. And it is bell or mound shaped, whatever makes more sense to you. All right. Well, let me scroll down for that next part. So for the next part, if you see that a distribution is normal, you are asked to perform some calculations, you have to describe it. So I know this sounds very redundant because sometimes they're going to say it's normal. You have to write down that it's normal. So if ever you're describing a distribution that happens to be normal, you want to say literally, it is normal, or actually I tend to say approximately normal, because nothing's ever perfectly normal. You want to state what the mean is, and you want to state what the standard deviation is. Many times that's given to you. A problem later, probably in the next video, it's given to us. And standard deviations, those are going to vary like with time and how we notate them, but right now you're just going to do that. And you can abbreviate this by writing normal, what the mean is, and what the standard deviation is. So you can literally write in parenthesis number, comma number. It looks kind of like a coordinate, and everyone knows the first number is the mean and the second number is standard deviation. All right, let's do one last thing to practice working with normal curves, and that's how to sketch them. So back to that opening graph of the Iowa test scores, they tell us that the mean is 684 and the standard deviation is 155. So many times a question on an FRQ problem, on like say part A of a problem, is to just sketch the distribution. So it's recommended that you go 3 standard deviations above and below. So draw for yourself a big bell curve. And then mark the mean. I didn't leave much room for myself at the top, so I'm going to call that the mean, and that is 684. And then I'm going to label standard deviations to the right and to the left. So I'm going to guess that's about 1 standard deviation. That's 2. Try and make them equidistant. And that's 3. So I like to write a sigma. Let me write a better sigma. 2 standard deviations and 3 standard deviations. And then let's go backwards. There's 1 below, 2 below, and 3 below. And then you got to do some adding and subtracting. So if I take 684 and I add 155 to it, I get 839. And maybe pause the video and do it yourself. Practice doing this. See if you can write underneath each vertical line that I drew. All right, I got 994. I got 1149. I got 529, 374, and 219. And this is typically how you would sketch a distribution. Label the mean and mark 3 standard deviations above and below. All right, we have a few more videos on this, so I will see you in the next one.